Hey everybody, welcome to 8.6. Today we're going to be talking about two unique laws in trig, and they are called the law of sines and law of cosines. So just as a reminder, up until now we've been working strictly with right triangles, and we've used Pythagorean theorem, we've used SOHCAHTOA, and we've used some special right triangle rules. But now we're going to be starting to deal with triangles that aren't right triangles, and this is where these two different laws come in. So the law of sines I have written here. Notice that I have a non-right triangle picture below, and the law of sines is simply just a bunch of fractions set equal to each other. So basically it's just proportions. So you'd have the sine of A over little a equals sine of B over little b, and then sine of C over little c. And I went ahead and put off to the side here a couple important notes. All the capital letters, A, B, and C, those refer to the angles of the triangle. And then little a, little b, and little c refer to the sides. And I went ahead and labeled in blue on this picture how we can find A, B, and C when they're little. So the trick is the side A is across from angle A, and side B is straight across from angle B, and same for C. So you always know that A and little a are going to be opposites of each other. Okay, so the one unique thing about law of sines is even though we have three fractions here, when you're actually using the law of sines, you're only going to ever use two at a time because you want to think of it as a proportion. So you only want two things so that you can cross multiply. All right, now when we're wanting to use the law of sines, there's basically three cases where we could use law of sines. The first is our angle, side triangles, okay, or we can have angle, side, angle, and those should be familiar from last semester when we talked about different measurements within a triangle. The other one, which we did not use last semester, was the side angle, and so now we're going to be talking about how we can use that to solve if we're given law of sines. Now, you won't see that very often, but just know that it's a possibility. And instead of necessarily memorizing these three different cases, I tend to find that the easiest approach to identifying the law of sines is to make a table of all your data. So in this example right here, I've got triangle A, B, and C. And the directions for this one would say solve for x. So what I'm going to do each time is I'm going to make a little table of all my information. So I'm going to write angle A, B, and C, and then I'm going to write little a, little b, and little c, and I'm just going to go ahead and fill in what information I know. Well, I know angle A is 78 degrees, and I know little a, which is across from it, is 8. And then I also know that angle B is 60 degrees, and I'm looking for little b, which is the x they have there. Now notice I don't have anything for row C, so I really don't need it in this case because remember we're only going to use two sets of letters at a time. So I'm just going to kind of ignore the third row for now. Now later you're going to want it, but for now when we're just starting off we don't really need it. So the trick to being able to tell if law of sines is going to work is to look at your table and see if you have a full row of information. So if we look here, I have a full row of all the A's, which means I am good to use the law of sines. And you'll see later in our other examples where you may not have a full row, and so you might run into some trouble. So because I know I can use law of sines because I have a full row, now I can just go ahead and plug in my proportion. So remember our proportion said the sine of the angle A, so sine of 78, over its side, so 8, has to be equal to the sine of angle B, which we just said was 60, over little b, which is the x. And now this is just a nice proportion that we could go ahead and solve by cross multiplying. So if I cross multiply, I get x times the sine of 78 equals 8 times the sine of 60. Now there's a couple different approaches that I would take in this. If you have a scientific calculator, what I would suggest doing is typing everything in all at once using some parentheses. But if you're not comfortable with your calculator, you're not sure how to do that, or maybe you have a really basic calculator to start, then you might have to change all of these answers to decimals. So I'm going to go ahead and do that just to show you what it would look like. So if I want to set everything or plug everything all at once, I'm going to go ahead and divide everything by sine of 78. And I'm doing that because I want my x's to be on their own. So I'm going to get x equals this whole fraction, 8 sine of 60 divided by sine of 78. And then what I would do is just go to my calculator and I would type in the top and then divide it by the bottom, and I would get my answer. And you should get, let's see, 8 sine of 60. Make sure your calculator is in degrees. Okay, divided by a sine of 78, you're going to get roughly 7.08. Now, if you don't know how to do that, or like I said, if you have trouble typing in your calculator, you can always go back and change everything to decimal. So I'm just rewriting this with decimal answers. So in your calculator, you could take 8 sine of 60. That's going to get you 6.9282. And then sine of 78 is going to get you 0.9781. So x times 0.9781. And then I can just divide both sides by that decimal. So here we're just dealing with a rounded version and then typing these numbers into our calculator. So it will get you the same thing. It's just two different ways of looking at it. If you do have to convert them to decimals, make sure you leave more decimal places at the beginning. That way your answer is more accurate at the end. Okay, so we found that x was 7.08, so that was our missing side length. Now, also keep in mind that you are dealing with sides and angles of triangles, so you don't want to get a negative answer for your solution. So if you do get x equals -5, then you need to rethink about how you set up your equation or how you solved, because obviously you don't want to have negative side lengths in these problems. So let's go ahead and take a look at example 2 in this case. I'm going to go ahead and set up my table to start, and just keep in mind I have Q, R, and S, but they don't have to, it's the same concept, it doesn't have to always be A, B, and C. Okay, so I'm going to set up Q, R, and S. And remember, the goal is to see if I have a full row of information. So I'm going to fill in what I know from my picture. So in my picture I know angle Q is 37, and I know that angle S is 54 degrees. And I know little s is the x, okay, so that's across from it. And I know little r, because it's across from angle r, is 10. But right now I don't have a full row, so that's a problem. But can I find a full row? So you want to always think about that. Well, the only other thing I'm really missing that would get me a full row is angle r. Well, could I find angle r by doing a quick calculation? Well, the good thing is these are triangles, and we should know that angles in a triangle add up to 180. So if I take 180 minus 37 and minus 54, then I can find that third angle measure. And then I would have a full row ready to go. So this gets us 89 degrees. So angle r is 89. And now, because I was able to find that full row, or that third angle, I now have a full row of information, which means I can use the law of sines. Now, because I'm looking for little s, I also want to use this information instead of the row Q. So I'm just going to ignore Q for a minute, okay, and then later if I needed to find something else, I'd go back to it. And now I just go ahead and fill into my proportions. So I'm going to say sine of angle R, so 89, over its side is 10, equals the sine of angle 54, angle S, over x. And now we can go ahead and cross multiply just like we did in the last example. So I want you guys to go ahead and try to cross multiply this one and then tell me what you get for your answer for this missing side length. All right, so we've just talked about the law of sines. Now we're going to get into the law of cosines. Now, I listed the law of cosines here. Notice there's 3 different formulas. They're all the same type of formula, just different variations of each other. And which one you use is just going to be dependent on what kind of information you're given. So you kind of just have to adjust. And law of cosines is going to be used in 2 cases, if you have side angle side or if you have side side side. And I'm going to do the same thing I did with law of sines and set up a table, okay, and when you don't have a full row and you can't get a full row, that's when you want to use law of cosines. So very important to know the difference of when you're going to use them. Okay, now if you notice in these 3 formulas, there should be something that looks very, very familiar to you, and that's the beginning part. So if you notice, it's a squared equals b squared plus c squared. Notice that each of these looks like Pythagorean theorem, so that's kind of an easier way to remember what the formula looks like. Okay, so it kind of looks like Pythagorean theorem. But then also notice that the number or the letters that come after this -2 are whatever is being squared after the equal sign. So we had b squared plus c squared, so bc should go here with the 2. Or a squared and c squared, so ac has to go here. Okay, and then also notice that the letter you started with here on the left has to be the angle that matches on the right. Okay, so little a has to go with big A, and little b has to go across to big B. So these have to match up. Okay, and these are just little tricks to help you remember the formula a little easier, since it is kind of an ugly formula. So let's go ahead and take a look at this example. I'm going to go ahead and set up my table just like we did in the first 2 examples. So we have D for both of these, and then G for both, and then angle F for both. And I'm going to fill in what I know. So I know angle G is 125 degrees, and I'm looking for little g because that's the x. I don't know angle D or F, so those are missing, but I do know little f is 15, and then the side here is 19. So notice I don't have a full row of information, and because I'm missing 2 angles, I can't find either of these, so I'm kind of stuck. I can't use law of sines, and that's where law of cosines comes in. So the trick here when you're trying to decide which formula to use, you always want to look at what information you have an angle or what you're looking to solve for. So here I'm looking for G, so I'm going to start off my equation with the letter G. So I'm going to have G squared equals, and then I'm going to use my other 2 sides. So D squared plus F squared minus 2 times, and remember it's these 2 letters, so D and F, and then times the cosine of the angle from the front. So I started with G, so I'm going to have angle G. And that's my formula. So now I just have to fill in what I know. So this is very important. You can tell the difference between capitals and lower cases. So I don't know what little g is, so I'm going to leave that as G squared. Little d here is 19, so we'll have 19 squared plus 15 squared, because that was F squared, minus 2 times D was 19, F was 15, and then times the cosine of angle G, which was 125 degrees. So I have my entire formula filled in. Notice I only have 1 variable missing, which is good. Okay, you can't have more than 1 variable missing. And now we just have to simplify our formula. Now, this is where people run into trouble. You have to think about order of operations. So I'm always going to do my exponents first, and then we're going to go to multiplication and division, and then lastly the addition and subtraction. Okay, so you have to think about PEMDAS. Very important. So if I simplify this, 19 squared is 361. So I'm going to get G squared equals 361 plus 15 squared, we get 225. And then minus, now I'm going to multiply all of this together. Very, very important. This is all one big multiplication problem. So I'm going to take 2 times 19 times 15 and then times the cosine of 125. And you can type all of that in your calculator at once and you should get negative 326.939. You want to give yourself a couple decimal places. And now I can go ahead and simplify. So I get G squared equals, if I add left to right, I get 361 plus 225 is 586. Okay, and then I have 2 negatives, and remember 2 negatives make a positive, so I'm going to add this here. Okay, now I can go ahead and combine those 2 numbers. Notice I'm working just left to right, so I get that G squared is equal to 912.939. And then how do I get G by itself? I'm going to go ahead and take the square root of both sides. So notice you want to take a square root of a positive number. So if you ever get a negative here, you're going to run into some problems. So always make sure that that answer is positive before you take the square root. And when we do that, we get G is equal to 30.21. Now, what it will tell you to round to will depend on the problem. So obviously make sure that you are reading the directions. Okay. Sometimes they want exact answers. Sometimes they want to the nearest whole number. Just it depends on the problem. So side G is 30.21, and then we'd be done. Okay, so it's kind of a longer process. Be very careful with order of operations. That's where people tend to make a lot of mistakes. But if you can get the formula started and plug in your numbers, most of it's just plugging and chugging into a calculator. Let's try one more example, and then I'm going to let you guys work on your own. So here I'm going to go ahead and set up my table just like we've done before. So A, B, little b, C, and little c. So in this case, we don't know any angle measures. So I'm not going to have anything in my angle column, but I do know all my sides. So little a was 15, little b is 12, and little c is 13. And maybe in this case, I want to solve for my angle c. So angle c is x. So I'm going to go ahead and set up my formula. So notice I'm looking for this set of information. Okay, no full rows, so you can't use law of sines, so we have to use law of cosines. So I'm going to use the c equation. So I'm going to have c squared equals a squared plus b squared minus 2ab, and then times the cosine of angle c. So now, if I'm going to go ahead and solve, I'm going to fill in what I know. Well, I have all the lowercase letters, so if I fill that in, I'm going to get 13 squared equals 15 squared plus 12 squared minus 2 times 15 times 12, and then cosine of angle C, which we don't know. That was the x. So now I have a problem because I have an angle with a missing measure. So this is where PEMDAS is still very important. So I'm going to go ahead and simplify everything that I can. So 13 squared is 169. 15 squared we know is 225. 12 squared is 144, so plus 144. I still have to multiply all of this stuff here together. Okay, so I'm going to multiply all of that. And when I do, I get 2 times 15 times 12. So I get minus 360 cosine of C. And now I have to think about order of operations. So remember, the goal is to find angle C. So I want to get that variable on its own. So what I'm going to do is move my other numbers in front over to the other side. And to do that, I'm going to first add them. So I get 169 equals 225 plus 144. That's going to get us 369 minus 360 cosine of C. Now notice I cannot subtract 369 and 360 because my 360 is connected with my cosine of C. So be very careful that you don't subtract these two numbers. It doesn't work. Instead, I have to move that 369 over to the other side. So I'm doing that in red, so we know we have to move it. So 169 minus 369, that's going to get you negative 200. Equals, then I'm going to be left with a negative 360 cosine of C. And now this is something I can solve. So I want to get cosine of C on its own, so I'm going to divide both sides by negative 360. And when I do that, I get 200 over 360, so I get 5/9. And I would try to leave things as fractions if you can. So we get 5/9 equals cosine of C. And if you think back to when we did SOHCAHTOA at first, remember if you're missing an angle, you have to use the second button. So I'm going to hit second cosine on your calculator. And when you type that in, you'll have the inverse, or that -1, and then you type in your fraction. So the cosine, the second cosine of 5/9. Making sure your calculator is still in degrees. And you should get that angle C is equal to 56.25 degrees. And then you'd be done. So this one is the kind of problem people tend to make mistakes on because they accidentally subtract two numbers when they can't. So be very careful that you wrote down this example. And if you're not quite sure what I did, that you ask me in class. So that way you guys are very comfortable with it. But your angle measure, 56.25 degrees, you should be good to go. And also a little side note, once you know this measure, 56.25 degrees, if you notice, now we have a full row of information. So if I then wanted you to figure out what angle B was, I could use this row of C's and then the row of B's, and I could switch to the law of sines. So the good thing is, even though law of cosines is really long, the law of cosines should only ever have to be used once, because once you've used it once, then you can switch to the law of sines and use proportions, and that will save you a lot of time. So never use law of cosines more than once. It's going to take you a lot more time than needed if you do that. Instead, if you have to use it once and then switch to the law of sines for the second part of your problem. And if you have any questions, feel free to ask me. Look at your other resources. You guys should be good to go. That's it. Thanks for listening.